Welcome back everyone to our final video here in section 2 of chapter 2. In this video we're going to be taking a graphical viewpoint. So our main goal is that if we're given a graph of a function, we want to be able to sketch the graph of its derivative. And the claim is, well, we saw that at the beginning of this section, the first video, I showed you a picture like this. We saw that actually computers are quite good at this game, right? So we went ahead and we had the graph of a function, and then we were able to graph its derivative at a bunch of points. And then those collection of points there became the derivative function. Now, on homework, on quizzes, on exams, right, we will not have calculators or computers to help us. But we still want to be able to pull off this same sort of trick. If we have the function, can we sketch the function's derivative? So that is going to be our goal for this video. And so an example that we're likely to see is something like this. Given the plot of each of these functions below, sketch their derivatives. So here's the function, and we would like to be able to sketch its derivative. And so the claim is, right, there's a technique, there's a good way to do these sorts of problems. And so I want to give you this technique up here. The first thing that you want to do is find where the derivative is 0. The claim is, this is a nice point. It's an easy one that we can identify here. We'll see as we get into this example. But we want to figure out where the derivative, aka the slope, is 0. Next, we want to determine the intervals where f is increasing or decreasing. So right, we already have the 0, so where is it increasing, decreasing? That's going to help us determine where that derivative will be positive or negative. Remember, if it's increasing, then it's going to have positive slope. Remember, derivative is just the same thing as slope. And if it's decreasing, then it has negative slope. Well, again, derivative is the same thing as slope. And then finally, we'd like to estimate the instantaneous rate of change at a few select points. So let's just say select points in each interval, just to get a few dots, and then we can connect those dots. All right, let's see how it's done. Using the technique, the first thing we want to do is figure out where the derivative is 0. That is that we have this slope is 0. So to me, staring at this one, I'm looking here at 3, right? Because if I was to draw a nice little tangent line, right, this tangent line would be horizontal, right? Or it would have slope 0. So that is a point where the derivative is 0. Okay, next up, you can kind of see that we've broken up this number line now at 3. So I'm going to kind of group together the stuff less than 3 and the stuff that's bigger than 3, and I'm going to try to figure out, is the function increasing or decreasing on each one of those intervals? So for instance, if I'm looking just between 0 and 3, looking at this, I think that it is decreasing, right? So it's decreasing, which means that it has a negative slope. So if it has a negative slope, that means that it's going to be down here below the x-axis. These are where all the negative values are. Remember, we're graphing the slopes. So again, decreasing means that it has negative slope, so it's going to be somewhere in this region. Now, after that, after 3, it looks like the function's increasing, right? As we move from left to right, it gets bigger and bigger and bigger. When it's increasing, that means it has a positive slope, which means that it should be somewhere up here in the positives, right? So somewhere up here. So that's where our graph is going to live. All right, now that we've kind of figured out this stuff, we're going to go ahead and estimate this instantaneous rate of change, or the slope of the tangent line, at select points. So let's go ahead and do that. So for instance, maybe at 1 here. If I was to go ahead and take 1 and try to figure out, okay, what is the slope? Well, let's go ahead and draw my tangent line here to kind of extend this a little bit. And I'll continue down here and up here. And we can see that, okay, well, it seems to be more or less, well, -1-ish. But we have to be careful with our scales here, right? Because our scales are actually by 5s here and by 1s here. So actually, I seem to go down 5. So if I go down 5, this is a run of 1. So if I was to do my rise or run sort of situation, right, this would be around -5. So I'm just going to go ahead and put here -5. And at 1, the slope seems to be around -5. Now, if you wanted to, we could do another one here, maybe at 2. But let's go ahead and continue on. Maybe let's do one at 4, right? So in the next interval here. So if I did at 4, and I go ahead and I draw my tangent line, try to figure out the slope at this point. Let's again think about a run of 1 here, and we want to know what is the rise. Well, in this case, the rise is indeed positive, right? It is a positive number. And in this case, I would say it's around, half of this entire thing, maybe a little bit less. So I'm going to say maybe a rise of 2 for a run of 1, remembering that these are by 5s in total, right? So 2 over 1, so this has a slope of 2. So if this is 5 up here, then maybe 2 is somewhere down here. So again, at 4, the slope seems to be right around 2. And maybe let's do one more of these points in this interval. Let's go over here. I'm going to do 7. That'll be a fun one. So over here at 7, let's try to figure out the slope here. So again, I'm going to draw my little tangent line, try to figure out what is the slope at this point. Again, we're going to do maybe a run of 1, and then a rise. How much is this rise here? So again, my run's 1, and the rise is going to be, let's see, there's 5 here, and then maybe another 3 or so. So I'm going to say somewhere around 8. Again, these are just estimates. They're sketches here. So I'm going to say around 8. So 2, 5, let's see, 8 up here, and that's right around at 7. So 7, slope 8. And then the last thing, right, if we want to sketch the derivative, well, let's go ahead and connect these points. So connect these points just like we did whenever we were sketching a function for the first time. So something like this. All right, there is a graph of the derivative. I think this was actually pretty good. Let's go ahead and try one more of these. I recommend pausing the video, trying to apply the same technique that we just did on this problem, and then unpause it, and I'll spoil the surprise for you. So try to get as far as you can. All right, I'll show you how far I made it. I figured out at 2 and at 5, it looked like the derivative was 0, right? It kind of levels out and it has a horizontal tangent line, aka slope 0. So I went ahead and plotted these, right? So if the slope's 0, let's go ahead and plot the slope over here. So at 2 and at 5, it's at height 0. Okay, then I went ahead and looked and I said, okay, between 0 and 2, is it increasing or decreasing? And it looks like it's increasing to me, right? As I move from left to right, it seems to get bigger and bigger and bigger. So that means that the slope of an increasing function, well, should be positive, right? So it should be somewhere up here. Then between 2 and 5, it looks like the function's decreasing. It's going down, so it should have a negative derivative or a negative slope. And then finally, between 5 and 8, or 5 and continuing on forever, at least as far as this graph can tell, it looks like it's increasing. So it should have a positive derivative up here. All right, and that's kind of where I left off. Now let's go ahead and do some just approximations, some estimates for select points, right? So estimate the instantaneous rate of change at select points in each interval. So we're on the final step here. So maybe if I go ahead and I take this point here at 1, this seems pretty natural. And again, we're trying to figure out what is the slope of the tangent line, aka what is the derivative here. So, okay, let me draw out my tangent line here. Again, we're going to do a run of 1, and we want to know what is the rise. Oops, wanted to use pink there, just to stay consistent. Okay, so this is still, right, runs of 1, and then the rise, we'll notice that these are jumping by 5s here, so I'm going to say that this is maybe around 3 or so. It's hard for me to be exactly sure, but I'd say around 3, right? If the entire thing's 5, that looks about 3-ish to me. So again, the rise over run in this case is going to be around 3. So maybe I'll go ahead and plot 3 right here. There we go. Okay, next up, if I was going to do maybe, let's do it 3. 3 here. So again, if I kind of draw my tangent line, something like this, and if I do a run of 1, how much is the rise? Well, it seems to be going down in this case. So let's see, the rise is, I would say, maybe around -2, maybe -1. Again, this is an estimate. So, okay, I'm going to say around -2. So if this is maybe -3, so -2 should be somewhere right around in here, -2. Okay, and now let's do one in the final region here. So let's go ahead and maybe I'll choose 7 again. So at 7, let's go ahead and draw our tangent line. Again, we'll have a run of 1, and we want to know how much do we rise. And to me, okay, so this bit maybe looks like 4-ish. This also looks like 4, so I'm going to say it's around 8-ish altogether. So 8 over 1, right? Rise over run. So that's around 8. So if that's 3, this is maybe 6. Here's 9. Maybe here would be 8. So 8, and this is at 7. And then finally, if you want to sketch this, right, we connect the points. So let's go ahead and connect these points. A nice smooth curve here. So maybe something like that would be our graph of the derivative. All right, that is the final example, and that's it for section number 2. I'll see you guys next time when we learn some kind of quick rules and tricks to be able to calculate out the derivative very quickly. See you then.